In this video, we're going to go over external control messages. These message steps are how you communicate with third-party hardware such as DIOs or RS232 devices. These steps are completely dependent on how you have your hardware configured. The first step will be to look at Setup Hardware External. This is assuming they have already been configured, which we go over in our hardware videos. If you look at the top, I have three interface types selected. The first one is an RS232 device, the second is an IEEE 488, which is a GPIB, and the third is simply set up as a foot switch. The first and the second will use message steps to control. The column of interface number is what we'll be using in our message steps. In the section below, I have enabled the DIO. I've configured 3 ports, port 1 and 3 are inputs, and port 2 is an output. All of these settings will affect our message steps. Now let's open a sequence and actually take a look at how we can control this hardware. We'll open up the message step templates, and I'll drag in the interface message. I'll double click on it. Over here on the left, on the radio button to select the message type, digital I/O and interface are what control our third-party hardware. Right now we have interface selected, so that is how we control our RS232 and GPIB devices. In this number dropdown, these are the 3 that are mapping to what we have selected for interface numbers in our external control tab. So 1 will display RS232, 2 will be GPIB, and 3 will be foot switch. As we change between these different devices, our functions will be different. For RS232, we can write and read messages, set control lines high or low, or read the control lines. If we switch to GPIB, you can see our functions are completely different, as well as the reading and the writing option. We have interface messages that are specific to GPIB. We have a serial polling option, and we have an option to wait for service requests. So here's an example of how we would write a message to an RS232 device. We'd make sure our interface number 1 is selected, we'd have the function configured to write or read messages, and then in the box below we would actually type in the command. Refer to your device manual for specific syntax. For example, in the manual of the Agilent, to initiate RS232 control, you must send a system:"remote" command with a line feed. There are a couple of specific termination characters that you can use to emulate line feed or carriage returns. So here we would type in system:"remote" and then enter the ASCII code for line feed. We also need to make sure that the step is set to write. Then we run the sequence and the command is set to our device. Now let's say we wanted to read the device. We'd stay on the write-read function, but change the setting to read. I'll also add a timeout of 5 seconds. This step will run for 5 seconds and try and read an RS232 message. We also need to make sure that our message step is set to display. I'll right-click on the step and select Display Step when run. I'll add in a time of 5 seconds here as well. So how this sequence would work, we would wait for 5 seconds to receive a message. Once we receive the message, the step will be displayed for 5 seconds. My RS232 device is going to send the message test. So here we'll click Run on the sequence, and you can see the red line at the bottom is the 5-second timeout. It received the message test, it stopped waiting, and displayed the step. In step templates, we have an example of a specific GPIB turntable device turn command. We'll drag it in, make sure to change our interface to number 2, and take a look at this message. The syntax of this command is turn rel 10, which will turn the device 10 degrees. And then we can specify at the bottom the message term or the address. Again, for all of this configuration, you'll need to consult the manual of your specific hardware. For example, here's another template for a turntable to rotate. As you can see, the syntax is completely different between the two. I'll just delete these steps from the sequence, and we'll take a look at the digital I/O step. We'll open up our first step, and change the message type from interface to digital I/O. Here in the drop-down of the ports, we can select 1, 2, or 3 because that's what we had configured in our hardware. You can see that 1 and 3 are input, and 2 is an output. The step is on input and set to pass. We can select which bits to read. I'm going to select 0, 1, and 2, and you can configure them off or on. My interface currently has all 8 bits high. If I run this step, it will read on port 1, and if the 3 bits that I have checked off, 0, 1, and 2, are high, the step will pass. Now I'll go in and edit the sequence, and set bit 0 to low. Now when I run the sequence, the step will fail because it does not match the configuration of my device. If we switch from port 1 to port 2, it will be on output. Running this sequence will always pass because I have it set to pass, and will output this configuration to the device. So it will set bits 0, 1, and 2 to off, on, on.